Okay, 4 p.m. I see people are still joining the room. So 30 seconds more for everybody to join us today. And we will start from introduction and slowly get into the features that SDC Verifier have developed and included into the newest release. So still see people coming in. And let's say 1 minute past 4, we are going to start. All right. Yeah, I think, those who are late will join us along the way. It's about time to start our webinar. So hello and welcome to What's New in SDC Verifier 2025 R2, our newest release that is going to be published officially next week. So this is a sneak peek preview into what is available, what is going to be available, what we have developed in the past half a year, and what features will become available to the users with this new version. So a brief agenda and a highlight of the features that we are going to speak about. We'll start with an introduction and where to find this newest version. We will speak about supported products, about a new way of reading results from ANSYS, about DPF result format, about possibility to log into to the analysis of LS-DYNA and post-process the analysis of LS-DYNA, about new standards. That's probably the biggest chapter. We have a lot of updates on this section to you. The single fillet welds and a small demonstration on how to do a weld check on single fillet welds, bulk profiles for stiffeners and not only, and their addition to the shape library and possibility to create it. I will briefly introduce SDC SAM, which is a big part of our development right now, and new things that we have developed on our website and with the web tools. As always, a quick disclaimer that everything that I'm going to show to you today is going to be shown either in SDC Verifier or SDC for ANSYS or Femap or Simcenter 3D. All of the features that we are developing are going to be or are already available for all of the users on all platforms. So whenever the feature is shown for SDC Verifier or ANSYS, it's also available for Femap. Going into this webinar, and I would like to start from the important difference, actually where to find and how to download this newest version of SDC Verifier. There is a clear distinction between new users and existing customers of SDC Verifier. The form on our website where you used to download SDC Verifier is now only for new users, is only for those who are trying SDC Verifier for first time, because it triggers the automatic issue of trial license. So if you're filling in the form on SDC Verifier website, you fill on all of your data and the correct corporate email, you will receive an automatic invitation to download SDC and to get your 15 days trial for free. So again, for all of the new users or those who are looking to start their journey with SDC Verifier, this is now super smooth and simple for you, an automatic procedure. You just fill in the form and follow the instructions in the email that you receive, and within a couple of clicks, you are having your copy of SDC Verifier and existing license for free for 15 days. For the existing customers, now you are able to download the software without filling in your data anymore, without new iterations of filling in the form on the website. You just go into the your own cabinet on mysdcverifier.com, either from software or just by typing into the browser search, and go to the products to download section, and there are all of your all of your downloads. You just click the button to download without resubmitting your data. So it's simplified for both new customers and existing users and those who want to try the software Again, if you're a new user, just download it from our website. If you're an existing customer, go into your personal cabinet and download the product that you require from the cabinet without resubmitting the data. New versions of the software are going to be available next week in your personal cabinet, so please refresh that page, and we will, of course, send a notification and another email with when it is finally available. As always, so we start our What's New webinar with the CAE products and FEA softwares that SDC Verifier supports as an extension and plugin. Most recent release of SDC Verifier is, of course, supporting the latest versions of Ansys Mechanical 2025 R2, but also Simcenter Femap and Simcenter 3D. And of course, we have enhanced and enriched our standalone version of SDC Verifier. So all 4 products that are available are going to be updated to the most recent version. And again, all of them are going to have all of the features that I'm showing today. Despite the small update that is only related to the Ansys users, because this is the way we are reading the data from Ansys. So for a long time, SDC Verifier was connecting through ACT plugin and reading the data from RTX file, I believe that was called. Now we switch to the most modern way of reading the data from Ansys, which is called DPF, Data Processing Framework. And this framework provides the operators that allow us to access the simulation data from coming not only from Ansys Mechanical, but also from other Ansys products and third-party result files. So all of the data files within Ansys environment are now going through this DPF format, and we will be able to read all kinds of data through this format. Why it is important? Because this is something that allows us to enhance our library of products, of Ansys products that we are connecting to. So from now on, it is also possible to use your LS-DYNA results for post-processing with SDC Verifier. So it is still done through Ansys analysis settings and through mechanical interface, but you import the results of LS-DYNA simulation into mechanical interface, and SDC Verifier is capable of connecting to those results and post-processing those results. So for all of those LS-DYNA users or those who run specific dynamic analysis with LS-DYNA and would like to do a post-processing with SDC or code checking with SDC on top of LS-DYNA results, this is nowadays possible, and this is a big enhancement for our Ansys portfolio. With this, let's go to the major updates and to the features that are available for all of the users, and we'll start with standards. There's quite a bit of different codes added into SDC Verifier, so I'll highlight some of them. I will also demonstrate the interface for a couple of those codes. So let's go one by one and speak over those codes. So we will start with BS7608. BS7608 fatigue check. This is pretty standard. This is British standard, which is pretty typical deterministic fatigue approach, very similar to what we have with Eurocode or with Australian standard, with definition of specific SN curves and materials. That's pretty much it. The definition of standard itself is pretty simple compared to typical fatigue standards in SDC Verifier. You define the environment. Is it in the air or in the seawater? You define the SN curve, and then if you want to take into account the reduced range, type of weld, material, yield and tensile, check if it's not zero, and then define the portion of model to check. So pretty similar, pretty standard, used for most steel structures worldwide, especially in United Kingdom, but also in the other countries, for structures like bridges, offshore structures, jackets, etc., but also machinery, equipment, lifting equipment, and so on and so forth. Another standard recently added to the library of SDC Verifier is DNV ST-0126, and it is not a typical code that we usually add to a standard, but we decided to include it because it was one of the most common questions. A lot of users have been asking, do you guys verify the models according to ST-0126? But the whole story is that DNV ST-0126 is only, in terms of structural checks, is only referencing to already existing and established standards that are already available in the library of SDC Verifier. So it directly refers that if you're doing buckling of members, you should do that according to Eurocode 3, or if you're doing tubular members, it's ISO or NORSOC. If you're doing welded connections, it is DNV. If you're doing tubular joints, again, ISO or NORSOC, and so on. So basically, when you're adding this, you will be redirected to the respective dialog window for the standard that refers to that creates the standard that refers to already established one in the library of SDC Verifier. And this will allow you to create multiple checks, like in this example for a topside unit, when the members are checked according to Eurocode, but then plate buckling is checked according to DNV. You can, of course, as with all of the standards in SDC Verifier, create multiple codes with multiple settings, and all of them within one project. Going to the weld strengths, we have updated our DNV OS C101, so DNV weld strengths code, to the latest version of 2024. Both RFD and WSD method are available. Obviously, the difference is in certain definition of loads and safety factors. So dialog windows are pretty much the same. The only difference is in terms of factors. And speaking even more about the single fillet, about the weld strength calculation, we have added single fillet welds into the calculation according to DNV OS C101, but also Eurocode 3 and all of the weld strength standards that are available in the library of SDC Verifier. And here is a little demonstration for you how that would work. Very simple example. As always, it all starts with recognition of welds. We obviously have only one weld here. Pressing highlight, we're seeing the weld line identified by SDC and stresses reoriented into the weld direction. Just for the sake of visualization, we'll turn the thickness on, and going back into the weld finder, we select weld strengths as a tab where we are selecting those weld part. And we're able to define not only full pan or double fillet, but also single fillet weld. Then the definition of dimension takes place either by size or by portion of throat thickness. And you need to select from which side of the welded part do you have that fillet, plus Y or minus Y. You define that, press OK. It's listed in the weld finder, and now the cool feature is that we are able to visualize not only the welded non-welded part, but also graphically to visualize the weld toe and from which side we have actually created. So for SDC Verifier, you do not need to model your weld specifically. We are identifying that weld line, but it's also possible to plot and visualize where this weld is. I'll pause this for a second. And this is currently shown again in SDC Verifier standalone interface, but it's also available in SDC for Femap, SDC for Ansys, and SDC for Simcenter. Graphics there also allows to visualize the welds. There is plenty of different visualization options. You can also visualize the reference points for the hotspot stresses and different types of the welds. So again, to a big benefit of SDC that does not require you to model the weld specifically because we identify that automatically. We now add nice visualization feature which clearly show at the moment where is non-welded part, welded part of our weld, and what is the type of weld designed in the weld finder, and that is going to be checked. So to check that, you just go to Standards, select Add, and pick any of the codes. In this case, we will pick Eurocode 3, define all of the parameters for the weld, set everything that you need, press OK, and then execute, right-click on the check, select the total weld check, and if we want to have a plot, we select overall utilization factor and call for plotting. Apparently, for bigger models and lots of loading combination, it takes more time. For a simple model with only one case, it takes a couple of seconds to solve, and then to plot the graphical representation of the results. And we could see it now. We see that in the welded part, it is completely red, and on the scale, it's higher than 1, the utilization factor. Therefore, we would like to know how much higher that is. We create a table. Again, all of the data is standard. We just press fill table, and we see that it's 7.4 times higher that this weld could actually withstand. That's not strange, because this model is actually prepared for the next big update, and you might see this in the list of standards that we have created. We're not only having Eurocode 3 welds now, but we also have added Eurocode 9 for aluminum structures. So this joint was actually designed for checking that model. Therefore, the result is so high. And this brings us to the next addition to the library, which is Eurocode 9. We are expanding from steel only into the library of more aluminum codes. We have DVS 1610 for aluminum. Now we have also added Eurocode 9 for weld strength. There is basically two main design requirements that we are checking. We are checking the design resistance of fillet welds, and then the design resistance in heat affected zones. The interface is extremely simple. The only parameter that you need to define is to use the detailed or general approach for heat affected zones thickness check, and and then the definition of the standard is the same as we've had for the steel structures. So if you're designing aluminum structures, it is available, it is there, and can be used in SDC Verifier 2025 R2. Continuing our list of standards that have been added into the library of the software, we are expanding with one more fatigue code, which is Australian standard AS4100 of the 2020, pretty recent one, that is replacing also, I believe, outdated AS3990, which we have for member checks, as well as we have member checks according to AS4100. But in this specific case, we have added the fatigue checks. Again, the definition and this standard is this standard approach is again the same for S&N curve method and deterministic fatigue, similar to what Eurocode does or BS7608 does. So the main characteristic here would be the definition of proper S&N curves, which are defined in the section called detailed category in this case, where you're selecting the proper S&N curve for the elements that we have defined as welds. We have done a specific example of this standard. As for all of the newly added standards to the library of the software, we are publishing the benchmarks where we are comparing the results calculated by SDC Verifier with the simple hand calculation method or with available benchmarks from certifying societies. So on our website, we're having the pages with benchmarks where you would be able to see all of those comparison documents as well as calculation procedures. Another significant standard for the energy industry and for those who are designing the floating structures or so is our extension to DNV RPC202. We have finally, it's been asked for quite a while, we have added the curved plate buckling check. So it is possible to do plate buckling checks according to DNV RPC202, also on the curved plates. Pretty much standard, again, is similar to what we already have in our library. You have to define would you rather read a stress on element, average plate stress, or the maximum on the element. And then if you're selecting the element, you're defining how you would like to read the stresses from those elements. So it's only a matter of which stresses we are using, and the dimensions are calculated automatically. And in this specific case, we have had to enhance our recognition tools because SDC Verifier was always finding the panels, section plates, and stiffeners. But in this specific case, we go to a panel finder, and we have in our model a possibility to identify curved plates. So if you would, after the recognition, go to a filtering page, select plates, and select filter rule curved, you select apply filter, and you see all of the plates that the software has recognized as curved. You see the column for that, and then the bend radius is calculated for all of this. So we can pick one of them, for example, and press preview highlight to see where it's actually identified. So yeah, the bottleneck for us adding this standard was the possibility to identify which plate is straight, which is curved, and then a possibility to define the radius. We were thinking about adding that manually, but then our development team managed to extract that from the FEA model. So we are able to read out the radius of the curvature. Therefore, we have all of the data necessary to calculate the plate buckling for the curved plates also. Okay, next addition to the software would be a possibility to create bulk profiles. So as you may know, in SDC Verifier, if you go to Settings tab, you'll see all of the libraries. And if you select Edit Library and select Shape Library, you will see all of the cross sections of the members that we have in the software. You can pick, filter out only bulk profile and see that the standard schedule of bulk profiles is added to that library. Moreover, it is possible to add that in the Properties menu. When you select right-click, Create Property from Library, that pretty much opens the same interface, which allows you to select the bulk profile. You pick that bulk profile, pick the material, and press Create. This adds the cross section. Again, this works in the same way the cross section library works for ANSYS and for Femap and for Simcenter 3D. So you're able to use those cross section either to map your existing shapes or to create new shapes, and then to use them in checks is our next goal. We are creating the variables and parameters for the bulk profile shapes. For the moment, it's possible to map it to the similar L shape, but in the next release, it will be also possible to use them as variables for the checks and to run plate buckling checks, stiffener buckling checks, and sneak peek into one of the next versions. We're also working on stiffened panels according to DNV. Okay. Next item would be our extensions and additions into the wind load tool. Again, shown on SDC Verifier interface, but wind load creates the distributed pressure of wind for ANSYS model and for Femap and for Simcenter models as well. And all of those tools, what you would have to do is to go to I'll mute the sound, is to go into the, I'll start it from scratch, into the interface of F.E.M loads, execute right click, add, and then you select from different types of loads. You select wind profile, give it a name, let's say in this case wind in X direction, define the vertical direction of your model and direction of wind. And a nice item here is that now it's possible to create not only one wind at a time, but for example, you're able to define a bunch of different winds, in this case from 0 to 180 degrees from X direction. We will create wind profiles every 30 degrees. Then you define the approach, how you would want to apply the pressure, its projected area, and drag coefficients are calculated automatically. You select the portion of model to verify. So in this case, we define all entities. And the wind profile, when I pre-recorded these videos, it looked slow to me. Now it's a bit too fast. So you select from the library of wind profiles, which you can store for yourself. You select the profile according to a specific standard, in this case F.E.M, and you identify either pressure or velocity over height. After that, there is a diagram. You click button OK. It applies the distributed pressure of wind into the model. As you can see, 1, 2, 3, 4, 5, 6 wind profiles have been created with different angle, with taking into account the drag coefficient for the sections, and applied to the portion of model which is subjected to that wind. And this is pretty much what was planned to be shown in this slide. Then a small update, but a big enhancement into the visibility and into understanding what's happening with your model when SDC Verifier. So there is a setting in preferences. So if you would go to File tab, Preferences, in the settings, there is a possibility to save the auto backup of your project every X amount of time. By default, I think it's set to 15 minutes, might be wrong, but anyway, everybody is able to set their own definition for this. And when this auto backup was saving, the model was freezing and you couldn't do anything with the project because there was an auto backup in the background and it looked like something is going wrong with the software. Now we have added the progress bar to this window. So when SDC is saving an auto backup, it's automatically it's indicating that, and you understand what's happening. Again, it is life-saving for certain projects to have this auto backup in case you, I don't know, computer glitches or you run out of computational power or some issues with the model or software appear. You don't want to get back, so it's important to set this auto backup, but also make sure you make it reasonable, because the bigger your model is, the more time-consuming the auto backup process is going to be. Okay, next item is a new functionality which has appeared in this new version, and it's a possibility to export your model into SDC SAM platform. In this case, this functionality is only available to the enterprise level, so to the customers with enterprise level license. And this functionality allows to export the data into SDC SAM. What is SDC SAM? It's a platform that we are currently extensively working on. SAM stands for Structural Asset Management, and this is a web-based platform for managing the structural integrity of your model. So we pretty much, in simple words, how to explain, typical FEA report or typical result report is static. So what you have analyzed you generate into the report in PDF or Word document, store it, send it to your customer. They store it somewhere in their file system, check it once when it's important, and then it's lost. But that's one iteration of the analysis that you have done, but the lifetime of the structure continues. So over time, you need multiple iterations of finite element analysis, multiple data sets, multiple design adjustments. So this is a dynamic web-based platform to export the structural information, in this case, the results of your finite element analysis, into the secure web platform where you can have multiple assets, all of the data about their structural components. Then you can link their loading data or usage data, inspection details, photos. You can create an inspection plan, define the usage history, and therefore link it to the damage history, and in the interactive dashboard showcase the health status, structural health status of your asset. So this is our next step to bring in simple wording, to bring reporting into the web platform, but also to give continuing data about the assets and continuing data about your designs to the customer, to the inspector, to the site manager or site operator. So different people with different level of access have possibility to log into the platform, either from office, from the calculation computer, or with your tablet on a screen when you're on site. Load the data, create the action points, tickets, highlight the potential problem spots, create the maintenance plan, and it is all powered by finite element analysis results. This is already set for a couple of ports operators, and it also works for multiple customers of ours who are either owning and operating the assets, but also for the consultants who are providing the results to the customer regularly. And these updates are not just another iteration, like report version 2, version 2 final, version 3 last. It's never last. I hope you're not naming your reports like that. For ongoing lifetime of your asset, it's a management system based on finite element analysis results. It's hard to explain with one slide, so we are soon going to have a demonstration of the functionality in a specific separate webinar. But what's been added in the functionality of SDC is possibility to export the data, the parameters. It's not only the results, but it's also the recognition parameters, structural parts, items of your model into the web interface of SDC SAM. If that's something that you're facing, feel free to reach out to me and we will set up a dedicated demonstration of SDC SAM features. And what's important also to understand here, it's a secure, so it's not one platform for everybody, it's a separate secure instance for every single asset group or every single company or every single customer. So there is no one cloud for everybody. Everyone has their own system, and we can set it up on your premises, on your cloud, on your server, etc. Okay, moving forward with the data, with the details about SDC Verifier. By the way, if you have questions, feel free to send them into the Q&A box, and we are going to answer them in the end. I see that there are some questions already. I'll answer all of those in the end. Speaking about new server and new licensing method, it has been launched in SDC Verifier 2025 R1. So since the beginning of the year, we are migrating our customer to new licensing system, which is not file-based anymore. You don't need to search for your files anymore. You just create an account, and it's one account for your web cabinet and for your login into the software. You fill in the email and password. You tick the checkbox box to remember you, and that's it. You logged into the software, and the data is saved. This allows you to have more transparency and more understanding what license do you have and how you use that. Again, this video is too quick. So when you are logging into the software and the license is successfully activated, you click in the top right corner onto your email address, and you go to the account, where you're able to see, okay, what license I'm currently utilizing and who's actually currently utilizing this license. There are also settings to go into the offline mode if needed, and to go to the web cabinet. Web cabinet is your place to see how the licenses are utilized, who's utilizing the licenses, but also to be able to download the newer versions. When you log in into your personal cabinet, there is a tab which is called Licenses and Users, where you are able to see, okay, these are the licenses that are available to my company. As you could see in this case, it's licenses for SDC Verifier, and we have 30 licenses of each. And you're able to see the current users. So this allows you to see, okay, who's currently utilizing the license, how many licenses are left available, and if there is no active licenses, this cabinet is still active. You go into the web cabinet and you see who of your colleagues is currently utilizing the software, so you can poke them and ask to, if there is not enough licenses. There is two ways. You can either poke them and ask to stop using so you can start, or you can reach out to us and increase the number of licenses for you. Of course, that's always allowed. And from this cabinet, you're also able to go into products to download. When you click on products to download, you're able to see the newest downloads. So if you're existing customers of SDC Verifier, please do not go through, the standard procedure of downloading SDC by filling your data on the website, because your license is already active and your downloads are already available in this cabinet. We can migrate that manually, of course, and move on, but now it's fully automatic and there's no need to fill in your credentials again and again. Okay, next addition in terms of web tools. As you could see, we're putting a lot of efforts into development of different solutions online as well. There is a specific free tool available for everybody for free to calculate the geometrical parameters and moments of inertia and centroids and etc. for different cross sections. It is available on the web on sdcverifier.com. Just Google free moment of inertia calculator. I'm pretty sure you'll be able to find it. And then you have this web interface of the tool where you can pick the cross section, when you can pick different cross section type, select the parameter, define the parameters, the dimensions, and the graphical representation of that cross section is automatically changing. Click calculate, and it automatically calculates the data like geometrical parameters, moment of inertia, but also elastic and plastic section modulus, radius of gyration, etc. And it works not only for standard schedule of cross sections, but for pretty much any shape of the defined groups, of course, any size of any shape. And then you click download results to see, to download the PDF report with this data. And it can be, of course, later on used as a cross-section in the library of SDC Verifier to design your structures with that cross-section. Important update from our marketing: we have launched completely new website, so new design, but also more information. In the learning and support tab, you have more tutorials, you have benchmarks, you have success stories from our customers, examples of FEA models. So if you're running some tests or you would like to just try SDC, you can also download models from there. Plenty of new information on the website, and plenty of new information available for both users of SDC and new customers as well. Speaking of that, I'd like to remind you that SDC Verifier trainings are available, and we do trainings both live and online, tailored to your workflow, to your specific models, to your projects, what you would like to know and learn. Feel free to reach out to book your training. Plenty of information is available on our YouTube channel, so please go to SDC Verifier on YouTube. There are recordings of previous webinars. There are step-by-step tutorials and instructions what to do. There are specific topics covered, like compliance with certain standards or definition of views, legend settings, advanced educational materials for the software as well. Everything is there. And of course, if you're missing something, let us know, and we are gladly converting the requests and questions from customers into the new content and new materials on both our website and YouTube. And with this, I would like to also point out what's possible, what we're planning to work on in 2026. As I already mentioned, we are looking forward to extend our buckling capabilities with stiffened panels according to DNV. We need to update the F.E.M to the most recent version. We will continue developing Eurocode 9 checks and aluminum checks, and also looking into other materials. If you're doing anything with concrete, for example, please let me know. We're looking into expansion into concrete as well. But of course, the higher the interest is, the higher is the priority for the team to develop this. Joint checks of API and NORSOC and AISC have to be updated to the most recent versions. They are all now converted into open checks, so you could see that in the library. But there are a couple of new versions of those standards, so we need to bring them to the most recent versions. We look to add plate buckling, new method for plate buckling, the edge stress method. That is most likely going to be already in the next release. We look into the options for parametric modeling. We work on enhancement of performance for all of the platforms, and we will continue expanding into structural asset management, into digital, into web-based iterative reporting and asset management and maintenance management. And of course, we are open to your suggestions. So if there is anything that you would like to add into the software or that you're missing in the software, please reach out, send out a message to me or support@sdcverifier.com or to our product owner. So we will add this into the list of into the long backlog of features that we plan to include. But the more it's requested, the higher is the priority for these features, of course. And with this, I would like to conclude the session for today. I was planning to keep it in under 45 minutes limit. We just managed to get into that. I'd like to go through the questions into the Q&A box. So if you still have any questions, please post them in the Q&A. I see one of the questions, it's asking, Harry is asking if the wind calculator is also considering shielding, and the answer is not. At the moment, it is not. You have to define shielding on your own, but if I'll quickly scroll to that, yeah, here it is. There is an interface to define the portion of the model subjected to wind. So in this case, I have here a selection, and what I am doing is I am just clicking on all button in a second, and all entities are included. But what you're able to do is to define the elements subjected to wind based on different, in this rule-based selector, where you can put them in by element type, property type, or what's more important, by coordinate. So you just measure the coordinate of your first edge or face and define all of those. And then you can add an extra wind profile with, I don't know, 70% of shielding or whatever shielding is there included. It's not ideal. It's not completely automatic, of course, but it allows you to create those complex wind profiles. So that is for sure possible. If you would like to have a tip on this or some help from us, just send a message to support and we will help you with that. I don't see any further questions in the chat box, so I'm assuming that that's it for the moment. Again, most of the questions usually arise when you're actually operating with the software. So from next week onwards, SDC 2025 R2 is going to be available in your personal cabinets. Feel free to upgrade. Me and my colleagues Bogdan and Pavlo are going to reach out to the existing users with your migration deadlines and notification about when the old server is going to be switched off. So don't delay the upgrade to the most recent version, because it brings a whole load of new standards. I didn't count, but I think it's about 7 new standards in this most recent version. So please, yeah, I still see a question over here. Yes, drag coefficients are determined automatically. They are determined according to EN 13001, F.E.M 1001, and Eurocode. We have either in plans or already implemented. I need to check. So yes, drag coefficients are determined automatically. Oh, sorry. They are determined automatically, but for a specific code. So if you are using Eurocode, it is there. If you're using specific standards, it's possible to create your own library of cross sections and drag coefficients, but that's something, yeah, that leaves an open question. But if it's a European standard, then drag coefficients are added automatically. Okay, thank you, Chris. Thank you for your questions. Thanks for your time and attention today. And again, feel free to give me a call, book a meeting, send an email to myself for support if you need anything from us. We're always happy to chat and help you to design better structures in the future. Thanks a lot, and looking forward to speak with all of you soon. Bye-bye.